So this exercise, we're finding perimeter and area. So that's kind of like a review of the exercises that we've already done. We know how to find perimeter of a lot of shapes, and we know how to find area of a lot of shapes as well. The only thing that's a little bit tricky about this exercise is that we're not dealing with regular shapes like rectangles and squares and things like that. We're actually dealing with composite shapes. So composite, if we look at that word composite there, that means that something is made up of different parts. So a composite shape is a shape that's made up of different shapes. And we can see in this example here, this shape is made up of a rectangle and a semicircle here, or a sector. And we know how to find the perimeter of a rectangle. That's pretty easy. We just have to add up all the sides, but we've got to be careful because we're not going to add up this side. So we need to really pay attention to the shape that we're looking at. And we know how to find the area of a rectangle as well. It's just going to be the length times the breadth here, which they've given us. And then with this shape, again, we know how to find the arc length because we've had a lot of practice finding the perimeter of sectors and circles. So we know that the arc length is just going to be a fraction of the circumference of the circle. And we also know how to find the area of a semicircle. It's just going to be half of the area of a circle. So we can find the area of this shape and the area of this shape, and then we can just add them together to find the area of the total shape, or the total area of the shape, should I say. And we can work out the perimeter too. We've just got to be a little bit careful that we don't include this line in the middle. So we're just going to be adding this side plus this side plus this side plus just the arc length here. And we have had a little bit of practice with questions like this. There were a couple of questions like this in our circumference and perimeter of sector exercise that we did in some of the harder questions. All right, so example 1, find the perimeter and area of this composite shape, round to 2 decimal places. Alrighty, so we need to find the perimeter first, and we can see, we just said that the perimeter is going to be equal to this side, so 17, plus this side, 14. It's just the edge of the shape, the outline of the shape, plus 17 again, plus the arc length. Now, how do we work out what the arc length is? So if we had a full circle here, if we can imagine that this wasn't a half circle, it was a full circle, and we wanted to find the circumference, we would use the formula circumference equals 2 pi r. But because we've only got half of that circumference, we don't have this other part of the circumference. It's just going to be a half of 2 pi r to find this arc length. So a half of 2 pi r, we can write that, a half of 2 pi, it's just going to be pi r, isn't it? A half of 2 pi r. But what's r? Instead of writing r, we're going to have a specific radius for this circle, and we need that radius to work it out. So what's our radius going to be? Can we see any information about the radius here? Well, I can see that in this rectangle, this side length here, the dotted line, is going to be equal to this side length here. So it has to be 14 centimeters. And this length here, this is our diameter of our circle as well. You can see that that dot in the middle indicates that that's the center of the circle. So this line must be the diameter. It goes through the center of the circle from one side to the other. And once we've got the diameter, it's really easy to find the radius because the radius is just half of that. It just goes from one side to the center and it doesn't go back to the other side. So half of 14 will give us the radius. So we have a radius here of 7. And that's all we really need to work out this question. Once we've got our radius, we can just plug that into our equation. 2 pi r is going to be 2 pi 7. And then we just need to evaluate this, and you can use a calculator because it says round to 2 decimal places. So 17 plus 14 plus 17 plus a half of 2 pi times 7. And we end up with 69.99 centimeters. So that's the perimeter. And the question also asks us to find the area. which I think is even easier. Basically, we just need to find the area of this rectangle, so all of this area inside here, plus the area of the semicircle, and then we'll have the total area. So the area is going to be the area of the rectangle, which is length times breadth, and we can see that the rectangle has a length of 17 and a breadth of 14. So our area for the rectangle is just going to be 17 times 14, plus we now need to add on the area of the sector. This is half of a circle. So the area of a circle is given by, area of a circle is pi r squared. We need to remember that formula. Circumference is 2 pi r, area is pi r squared. So we have to be careful that we don't get these confused. So if this was a full circle, we would use pi r squared. But because it's only half of a circle, we're going to use half of pi r squared. So our formula is going to be a half of pi. Now what's our r? Our r was 7. It's still the same radius. Pi 7 squared. And now we've got all numbers here, we can just evaluate that on a calculator. All we did was the area of the rectangle plus the area of the semicircle. So 17 times 14 plus a half of pi times 7 squared. And we end up with an area of 314.97. And remember, this is square centimeters because we're talking about area now. So there you go. We found the perimeter of the shape, which was just the outline, and the area of the shape, which we just had to add these two shapes together to find the total area. Okay, example 2 asks us to find just the area of this composite shape. So we're not really interested in perimeter for this question. We just need to find the area. And sometimes when we're dealing with area of composite shapes, it's easier to use subtraction to work out the area. I can see in this shape, I've got a square, and then it looks like there's been a trapezium taken out of the square. So if we find the area of the square and then subtract the area of the trapezium, it's kind of like we're taking out that trapezium and we're just going to be left with this area here, which is the composite shape. That's what we want to find. So we're only interested in finding this area here. So we need to find the area of the larger square and then subtract the area of the trapezium from that area. So what's the area of a square? The area of a square is just length squared. And our length is 6 here. We've got all side lengths of 6 meters. So our area of the square is just going to be 36 square meters. So that was easy. And now we need to find the area of the trapezium so that we can subtract that from the area of the square. So area of a trapezium, let's just call this area of a square, sorry, and this is area of a trapezium. So we can remember which area is which. So the area of a trapezium is given by a half of the height times the sum of the two parallel sides, A and B. So for our trapezium, have we got the height? Yes, we've got the height of the trapezium. It has to be the perpendicular height from one parallel side to the other. So that's 3 meters for H. So we can plug that in. So a half of 3 times, now we need to find the sum of the two parallel sides. Do we have the two parallel sides A and B? Well, we've got one of the parallel sides. You can see that this side is parallel to this side, by the way, so these are the parallel sides. We've got 3, so we can say A is 3. And what's the other side? The other side is this length up here, and we do know what that is because it's just the opposite side in the square. So it has to be 6. So this is our formula. We just need to evaluate this. We can do it on the calculator if we like. A half times 3 times 9, or 3 plus 6. And we end up with an area of 13.5 square meters for the trapezium. So now that we've got our area for our larger square is 36 square meters, and our area for our little trapezium here that we need to take out of the square is 13.5 square meters, all we need to do to find the area of our shape, or the total area, is 36 minus 13.5. So 36 minus 13.5, we end up with 22.5. So that's our total area for the composite shape. And we use subtraction, whereas in the previous example, we actually used addition. You can see that for this example, we found the area of the rectangle and the area of the semicircle, and we added them together because this shape is made up of both areas. But for this one, it's like there was an area missing here. So we actually needed to subtract this area from the area of the square.